Have you ever imagined looking up at the night sky and seeing lights slowly dancing above your head? Green, purple, pink, and bluish lights moving like curtains, spirals, or silent waves across the dark sky. This breathtaking phenomenon is called the Northern Lights, or Aurora Borealis. And no, it isn't magic, but it comes very close. Before we begin, let me ask you something. If you could travel anywhere in the world right now just to see a natural phenomenon, would you choose the Northern Lights? Do you think they make any sound, or are they completely silent? Let's find out together. What are the Northern Lights? The Northern Lights are a luminous phenomenon that occurs mainly in regions close to the North Pole, such as Norway, Iceland, Finland, Canada, and Alaska. In the Southern Hemisphere, they also exist, but under a different name, the Southern Lights, or Aurora Australis. Although they look supernatural, the Northern Lights are the result of an extremely complex scientific process involving the sun, invisible particles, Earth's magnetic field, and gases in our atmosphere. Here's a surprising curiosity to start with. The aurora doesn't happen in the sky like clouds or stars. It occurs within Earth's atmosphere at altitudes between 80 and 500 kilometers. So yes, it's much closer than most people imagine. It all begins with the sun. To understand the Northern Lights, we need to start very far away from Earth, at the sun. The sun isn't just a giant ball of fire lighting up our days. It's incredibly active and constantly releasing energy, heat, and electrically charged particles. From time to time, massive explosions occur on the sun's surface. These are called solar flares or solar storms. During these events, the sun releases enormous amounts of particles, mainly electrons and protons, that travel through space at very high speeds. This constant flow of particles is known as the solar wind. Now, think about this. These particles travel millions of kilometers through space, and some of them end up reaching Earth. But if the sun is constantly sending particles our way, why isn't Earth being constantly bombarded? The role of Earth's magnetic field. Earth has something essential for life, its magnetic field. It works like a giant invisible shield surrounding the planet, protecting us from most of the dangerous solar particles. When the solar wind approaches Earth, the magnetic field deflects most of those particles. However, and this is the key point, near the poles, this magnetic shield is weaker. This allows some particles to enter the atmosphere, mainly near the North and South poles. That's why the Northern Lights don't appear everywhere in the world. They are fundamentally a polar phenomenon. Had you ever thought that Earth's own shield helps create such a beautiful light show? The collision with the atmosphere. When these solar particles finally enter Earth's atmosphere, they collide with gases such as oxygen and nitrogen. These collisions release energy, and that energy appears in the form of light. It's very similar to what happens in neon signs. A gas receives energy, becomes excited, and emits light. And now comes one of the most fascinating curiosities. Why do the Northern Lights have different colors? The colors of the aurora depend on two main factors: the type of gas involved and the altitude where the collision occurs. Here are some examples. Green, the most common color, caused by oxygen at about 100 to 150 kilometers in altitude. Red, also caused by oxygen, but at higher altitudes, above 200 kilometers. Purple and blue, caused by nitrogen. Pink, a mixture of oxygen and nitrogen emissions. Now, a question for you listening right now. Which of these colors would you most like to see in the sky? Did you imagine that altitude could influence color? Why do the Northern Lights dance? One of the most mesmerizing aspects of the Northern Lights is their movement. They don't stay still. They ripple, stretch, curve, and seem to slowly dance across the sky. This happens because solar particles follow Earth's magnetic field lines, and these lines are not straight. They are constantly shifting and moving. On top of that, changes in solar activity can make the aurora change shape within seconds. Every aurora is unique. No two displays are ever the same. It's like a live performance by nature itself. Do the Northern Lights make sound?
This is a controversial and fascinating question. For a long time, scientists believed the northern lights were completely silent. However, some people who witnessed very intense auroras reported hearing soft crackling sounds, whispers, or noises similar to electricity. More recent studies suggest that under rare conditions, electrical discharges close to the ground may generate sounds synchronized with the aurora. Can you imagine hearing the sky? If you were there, would you notice the sound or be surrounded by total silence? Ancient peoples and the northern lights. Long before science explained the aurora, ancient peoples observed it and created stories to understand it. For example, the Vikings believed the aurora was the reflection of the Valkyries' armor. Some Inuit cultures believed it was spirits playing ball with a skull. In certain cultures, the aurora was a sign of good luck. In others, it was seen as a warning or an omen. This reveals something beautiful. Even without science, humans have always tried to find meaning in the beauty of the sky. The northern lights and technology. The aurora isn't just beautiful, it can also cause problems. Strong solar storms can interfere with GPS signals, affect satellites, cause power grid failures, and disrupt radio communications. So yes, the same phenomenon that amazes tourists can challenge engineers and scientists. Quick curiosities to impress. The aurora can occur during the day, but sunlight makes it invisible. Other planets like Jupiter and Saturn also have auroras. The stronger the solar activity, the farther south the aurora can be seen. There are apps that alert you when aurora activity is high. To conclude, the northern lights are more than a scientific phenomenon. They are the result of an invisible connection between the sun and earth, between space and atmosphere, between energy and beauty. I'll leave you with a few final questions. If you were standing beneath an aurora right now, how would you feel? Would you stay silent or try to capture everything on your phone? Are some moments too beautiful to be recorded? Perhaps the greatest curiosity about the northern lights isn't how they happen, but why they move us so deeply.